Welcome to the InventorCAM Professor video series called Jumpstart, the easy way to learn InventorCAM. In this session, we will be going through part 4 of our first lesson, where we will add a profile operation to our CAM part and then run through our workflow in the operation dialog. Here we have our CAM part with a Facemill operation from the previous video. If you are starting the lesson here, please download the InventorCAM part file included with this video tutorial and open it. We have been saving all of our downloaded part files in a training folder that we've created on our C drive. Now that our Facemill operation is complete, we can add a profile operation to machine the outside dimensions of our part. Once again, we right-click on Operations, highlight Add Operation, and select Profile. When our profile operation dialog opens, you will notice the workflow is very similar to what we saw when creating our Facemill operation. We will start by defining our geometry. We are going to select a chain that runs around the perimeter of our part. There are multiple options available to us when defining our geometry, and we will discuss 2 of these options in this example. The first option is to start by selecting an edge. Then, one at a time, click and highlight all subsequent edges until we have worked our way around to the beginning. Take notice, when selecting an edge, this red arrow appears. This arrow represents machining direction, and you should be aware of whether you want to perform a conventional or climb cut. Also, the point where the mouse arrow is sitting when we select the first edge will be the initial XY position in our G-code. This gives us control over where we would like our profile machining to begin. Now we can take a look at our second option of chain selection, Auto Constant Z. First, we will need to reject our initial chain by clicking on the Reject Chain button. Now let's start by picking a single edge for our chain and then select the Auto Constant Z option. As you can see, rather than click on individual edges to construct our chain, this function automatically grabs every edge located on the same Z level and connects them to our initial edge selection. With one easy step, we were able to create this entire chain. Click Yes to accept the selection, and then click Finish to exit the Geometry Edit dialog. Our geometry is now defined. Next, we need to create our tool. Once in our tool dialog, let's click Select. The only tool we have defined so far is our Facemill, which would not be acceptable for our profile operation. So let's click on the Add Milling Tool icon and choose an end mill. We will use the default tool values for this exercise. We can also add a tool holder to our end mill by clicking on the Holder tab. Check the Use Holder box. Here we have a series of different holders available under the Global tab. Let's grab the first choice in the list. You'll also notice if we drag our mouse onto our tool picture display, we can view the tool and tool holder in real time. Any changes we make to the tool are updated visually and can be viewed on the fly. For example, we can see that our tool is extending out of the holder quite a bit. Let's go back to Topology and decrease the outside holder length to 40 millimeters. We can see that the tool picture has been updated. With the tool now defined, let's move on to levels. We have the ability to pick our levels right off the model. Simply click on the upper level button. Then we can pick the feature that represents the top of our target model. Our profile depth is handled in the same manner. Simply pick the feature off the model that represents the profile depth. Delta depth is available to control profile depth even further. For example, let's say we want to leave an extra 0.5 millimeters at the bottom of our part. We can enter 0.5 millimeters in this field, and our tool will feed in the Z-axis 0.5 millimeters short of our profile depth. Conversely, We can enter negative 0.5 millimeters and our tool will feed 0.5 millimeters past our profile depth. The direction of the delta depth measurement is represented by the arrows next to the input field text box, with a corresponding positive or negative symbol. It is also represented graphically here on the left. We will leave it at 0 for this lesson. Our technology branch is up next, where we can start with tool side. This controls what side of our selected geometry we will be working on, and our choices are right, left, and center. We will be using left for this lesson. The compensation box handles whether or not we want to use cutter compensation when we output our G-code. If we put a check mark in our rough option, we can do both a rough and finish pass. We can leave extra material on our wall, then have the tool come back and machine off the excess material. In this case, we will make our wall offset 0.3 millimeters and we'll leave our rough step down at 3 millimeters. We will leave the number of passes for our finish cut at 1, meaning our tool will come down to the profile depth and remove the 0.3 millimeters on the wall in a single pass. Lastly, we will move on to link. This controls how we would like our cutting tool to enter and exit our part. When we select the drop-down menu under Lead In, we have 6 options. Whatever option we select, the diagram on the left shows us visually how the tool will lead into the cut. For this exercise, we are going to use an arc lead in and we will set the value to 4 millimeters. This means our tool will make a 4 millimeter arc into our profile cut. Now we have the same options available to us in lead out. To simplify our selection, let's check the same as lead in box. If we check this box, our lead out type will be the same as our lead in. It will set the value to match, 4 millimeters in this instance. Finally, we can save and calculate our operation. And this concludes part 4 of our first lesson in the InventorCAM Jumpstart Series, where we've added a profile operation to our CAM part and ran through the operation dialog. Thanks again for watching. Please join us for part 5 of our first lesson, where we will simulate our profile operation toolpath and show other ways of navigating to the simulation dialog.